Adding new outlets to an existing circuit is generally permissible if the circuit meets specific requirements outlined in the National Electrical Code. Firstly, the existing circuit must be in good condition and free from any defects. Secondly, the circuit should not be overloaded, meaning its current load is below its ampacity limit. Thirdly, the addition of new outlets must not increase the total load in the circuit beyond its ampacity limit. It is crucial to remember that some jurisdictions may have more stringent local building codes that place additional restrictions on added outlets to existing circuits, particularly if the circuit doesn't comply with current code standards. These local codes may mandate that all circuits be upgraded to meet current code standards before any new outlets can be added. Even if it's not explicitly prohibited by law, adding new outlets to an overloaded or unsafe circuit can create a significant safety hazard. Overloaded circuits can overheat, leading to fires or electrical shock. The recommended approach is to always prioritize safety and compliance. Before adding any new outlets, it's generally recommended to upgrade the circuit to meet current code requirements. This could involve installing a new circuit altogether or increasing the capacity of the existing one. Take, for example, a situation with a 15-amp circuit. Adding a whirlpool motor to the circuit would likely overload it and create an unsafe condition. In such a case, it's strongly recommended to upgrade the circuit to a 20-amp circuit before installing the whirlpool motor. The determination of whether to add new outlets to existing circuits requires careful consideration of electrical code requirements, local regulations, and safety factors. While there may not be a universally clear legal consensus on adding new outlets to circuits that don't fully comply with current codes, prioritizing safety is paramount. To ensure the safety of the dwelling and its occupants, it's advisable to upgrade any non-compliant circuits before adding new electrical devices or outlets. The ampacity of a conductor is the maximum amount of current, in amps, it can carry continuously without exceeding its temperature rating. Several factors can affect the ampacity of a conductor, including its size, material, insulation type, and the ambient temperature in which it is installed. The National Electrical Code, or NEC, provides tables that list the ampacities of different types of conductors under various conditions. When determining the appropriate size of a conductor for a particular circuit, it is essential to select a conductor with an ampacity that is sufficient to carry the anticipated load. Overloading a conductor can cause it to overheat, which can damage the insulation and potentially lead to a fire. A circuit is considered overloaded when the current flowing through it exceeds its ampacity. This can happen if too many devices are plugged into the circuit or if the devices draw more current than the circuit is designed to handle. Common signs of an overloaded circuit include tripped circuit breakers, blown fuses, flickering lights, and outlets that are hot to the touch. If you suspect that a circuit is overloaded, it is essential to take steps to reduce the load or upgrade the circuit to a higher ampacity. This may involve unplugging some devices, moving some devices to a different circuit, or installing a new circuit with a higher ampacity. In addition to overloading, other factors can also contribute to unsafe electrical conditions such as damaged wiring, loose connections, and improper grounding. It is crucial to inspect electrical systems regularly and address any potential hazards promptly. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the inspection and any necessary repairs. The National Electrical Code is a set of standards for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is widely adopted by state and local governments as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of electrical systems and preventing electrical hazards. Electrical codes are in place to safeguard people and property from electrical hazards. They provide a uniform set of rules and guidelines for the safe installation and maintenance of electrical systems. These codes are often based on the National Electrical Code but may be amended or supplemented by local jurisdictions to address specific needs or conditions. It is crucial to be aware of and comply with all applicable electrical codes when performing any electrical work. Failure to do so can result in fines, penalties, and, more importantly, increased risk of electrical hazards. When working with electricity, always follow safe work practices. Firstly, always turn off the power to the circuit you are working on before starting any work. Secondly, use insulated tools and equipment. Thirdly, never work on electrical systems in wet or damp conditions. Fourthly, be aware of your surroundings and avoid contact with any energized parts. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Grounding is a critical safety measure that helps to protect against electrical shock. It provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. All electrical systems should be properly grounded in accordance with the NEC. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. The grounding conductor, typically a green or bare wire, connects the grounding electrode to the equipment grounding system. Equipment grounding ensures that the metal enclosures of electrical equipment are at the same potential as the earth, reducing the risk of electrical shock. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against electrical shock by monitoring the current flowing through a circuit. If the GFCI detects a difference in current between the hot and neutral conductors, it will trip the circuit, cutting off the power. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. Arc fault circuit interrupters, or SIs, are devices that are designed to protect against fires caused by arc faults. Arc faults are dangerous electrical discharges that can occur when there is a break or weakness in the insulation of a wire. SIs detect arc faults and trip the circuit, preventing a fire from starting. SIs are now required in many locations such as bedrooms and living rooms, where arc faults are more likely to occur. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They work by interrupting the flow of current when it exceeds a predetermined level. Circuit breakers are resettable devices that can be tripped manually or automatically. Fuses are one-time devices that must be replaced after they blow. The size of the overcurrent protection device must be appropriate for the ampacity of the circuit. Using an undersized overcurrent protection device can result in nuisance tripping, while using an oversized overcurrent protection device can allow the circuit to become overloaded and potentially cause a fire. Wiring methods refer to the ways in which electrical wires are installed and protected. The NEC specifies various wiring methods that are permitted for different applications. Common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, electrical metallic tubing, or IMT, rigid metal conduit, or RMC, and liquidite flexible metal conduit, or LFMC. The choice of wiring method depends on factors such as the environment, the type of occupancy, and the voltage of the circuit. Proper installation of wiring methods is essential for ensuring the safety and reliability of electrical systems. Electrical boxes are enclosures that are used to protect electrical connections and devices. They are typically made of metal or plastic and are available in various sizes and shapes. Electrical boxes must be properly sized to accommodate the wires and devices that they contain. They must also be securely mounted and properly grounded. The NEC specifies the types of electrical boxes that are permitted for different applications. When selecting electrical boxes, it is important to choose ones that are appropriate for the environment in which they will be installed. For example, weatherproof boxes are required for outdoor locations. Conductors are the wires that carry electrical current. They are typically made of copper or aluminum and are insulated to prevent electrical shock. The size of the conductor must be appropriate for the ampacity of the circuit. The NEC specifies the types of conductors that are permitted for different applications. When selecting conductors, it is important to choose ones that are suitable for the environment in which they will be installed. For example, conductors that are exposed to moisture must be rated for wet locations. Electrical panels are enclosures that contain circuit breakers or fuses that protect the circuits in a building. They are typically located in a central location such as a basement or utility room. Electrical panels must be properly sized to accommodate the number of circuits in the building. They must also be properly grounded and labeled. The NEC specifies the requirements for electrical panels, including the location, installation, and labeling. When working on electrical panels, it is essential to follow safe work practices to prevent electrical shock. Always turn off the main power before working on the panel. Use insulated tools and equipment. Never work on electrical panels in wet or damp conditions. If you are not comfortable working on electrical panels, hire a qualified electrician. Lighting is an essential part of any building. It provides illumination for tasks, creates ambience, and enhances safety. The NEC specifies the requirements for lighting, including the types of fixtures, the location of fixtures, and the control of fixtures. When selecting lighting fixtures, it is important to choose ones that are energy efficient and appropriate for the application. For example, LED lighting is becoming increasingly popular due to its energy efficiency and long lifespan. Proper installation of lighting fixtures is essential for ensuring safety and performance. Electrical appliances are devices that use electricity to perform a function. They range from small appliances, such as toasters and blenders, to large appliances, such as refrigerators and ovens. The NEC specifies the requirements for electrical appliances, including the wiring, grounding, and overcurrent protection. When selecting electrical appliances, it is important to choose ones that are energy efficient and safe to use. Follow the manufacturer's instructions for installation and operation. Regular maintenance of electrical appliances can help to prevent electrical hazards. Electrical safety is a critical concern for homeowners and businesses. By following safe work practices and complying with electrical codes, it is possible to reduce the risk of electrical hazards. Regular inspections of electrical systems can help to identify potential problems before they become serious. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the inspection and any necessary repairs. Remember to always prioritize safety when working with electricity. Electricity can be dangerous if not handled properly. By following the guidelines and recommendations outlined in this discussion, you can help to ensure the safety of yourself and others. When dealing with electrical work, it's always recommended to consult with a qualified and licensed electrician to ensure that all work is performed safely and in compliance with applicable codes and regulations. This is especially important when dealing with older electrical systems, as they may not meet current safety standards. The presence of a 15-amp circuit serving multiple loads, including a bathroom and bedrooms, is a common scenario in older homes. However, it is generally not recommended to add additional loads to such a circuit, especially a high-demand appliance like a Whirlpool tub. It's crucial to determine the total load in the existing circuit and compare it to the circuit's ampacity. The load calculation should include all connected devices and appliances, taking into account the wattage or amperage ratings. If the total load exceeds 80% of the circuit's ampacity, it's generally considered overloaded. In the specific case of adding a Whirlpool tub to a 15-amp circuit already serving a bathroom, bedrooms, and lights, it is highly likely that the circuit would become overloaded. A Whirlpool tub motor can draw a significant amount of current, potentially exceeding the circuit's capacity and creating a safety hazard. Upgrading the circuit to a 20-amp dedicated circuit is the recommended approach in this situation. This would provide sufficient capacity for the Whirlpool tub motor without overloading the circuit. A dedicated circuit ensures that the Whirlpool tub is the only appliance connected to that circuit, minimizing the risk of overload and improving safety. In addition to upgrading the circuit, it is also important to ensure that the wiring is in good condition and that all connections are secure. Loose or corroded connections can create resistance, leading to overheating and potential fire hazards. It is recommended to inspect the wiring and connections and replace any damaged or deteriorated components. Grounding is another critical aspect of electrical safety. Ensure that the whirlpool tub and the electrical circuit are properly grounded to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Ground fault circuit interrupters, or GFCIs, are also highly recommended for bathroom circuits, especially the serving whirlpool tubs. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock. GFCIs should be installed in all bathroom receptacles and circuits serving whirlpool tubs. When upgrading the electrical circuit, it is important to comply with all applicable codes and regulations. This may involve obtaining permits and inspections from the local authorities. A qualified electrician can ensure that the work is performed in accordance with code and that the electrical system is safe and reliable. If the existing electrical panel is old or outdated, it may be necessary to replace it with a new one that has sufficient capacity to accommodate the new circuit. Electrical panels have a limited number of spaces for circuit breakers, and if the panel is full, it will not be possible to add a new circuit without replacing the panel. Replacing an electrical panel is a complex task that should only be performed by a qualified electrician. The electrician will need to disconnect the existing wiring, remove the old panel, install the new panel, and reconnect the wiring. It is important to ensure that the new panel is properly grounded and labeled. In addition to the electrical considerations, it is also important to consider the plumbing requirements for installing a whirlpool tub. The tub will need to be connected to a water supply and a drain. The plumbing connections must be properly installed to prevent leaks and water damage. It is recommended to hire a qualified plumber to perform the plumbing work. The plumber will need to install the water supply lines, the drain pipe, and the overflow drain. The plumber will also need to ensure that the tub is properly leveled and supported. Before starting any electrical or plumbing work, it is important to obtain all necessary permits from the local authorities. Permits are required for most electrical and plumbing work, and they help to ensure that the work is performed in accordance with code. The permit process typically involves submitting plans and specifications to the local building department and paying a fee. The building department will review the plans and specifications to ensure that they meet code requirements. Once the permit is approved, the work can begin. After the work is completed, the building department will inspect the work to ensure that it was performed in accordance with code. If the work passes inspection, the permit will be closed out. Failure to obtain permits can result in fines and penalties. In some cases, the local authorities may require that the work be removed and reinstalled with a permit. It is always best to obtain permits before starting any electrical or plumbing work. The information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. Electrical and plumbing work can be dangerous and should only be performed by qualified professionals. Always consult with a qualified electrician and plumber before starting any electrical or plumbing work. By following these guidelines and recommendations, you can help to ensure the safety and reliability of your electrical and plumbing systems. Remember to always prioritize safety when working with electricity and plumbing. If you are not comfortable performing the work yourself, hire a qualified professional.